All right, so today we are continuing with chapter 11. This is day 6. In your notes packet, it will be labeled 11.7. This is all about multiplying and dividing with radicals. Jumping right in. Here's our first example. So I keep talking about who's outside, who's inside. Yeah. If you are inside, do you think you get to play with the people that are outside? No. But can you play with those that are inside? Yeah. So the outside people play with the outside people, and the inside people play with the inside people. So I am going to multiply the 5 and the 3. They're both playing outside. They're good to go. I'm also going to multiply the 2 and the 8. They're stuck inside, so they're going to play together. All right? Knock it off. Knock it off. Boom. Now, do you think that that's the answer? No.
Yeah.
We would never leave a square root unsimplified, especially a perfect square. What is the square root of 16? 4. And now they're all outside. Woo! 60 is the answer. What are your questions? And it's a beautiful day to play outside. See how I did that? Okay. What are your questions? They all have friends. Now we got everybody's outside. Okay. Shh. Okay. Shh. Shh. We're not really going outside. I mean, you can later, but not right now. No. Okay. Who's outside?
4 and 7.
The 4 and the 7, they're going to multiply. Who's inside?
15.
The 15 and the 3, they're going to multiply. Now, that gives me 28 on the outside, 45 on the inside. I can do a tree for the 45. It's 3 and 15, 3 and 5, and who's busting out?
3.
The 3s. Now the 3s are outside. Poor 5 stuck inside. 3 times 28 gives us 84 square root 5.
That's a lot.
So what do I do?
Multiply.
Yeah, everybody's inside.
200.
Must be raining, okay? So 10 times 20. We get 200. Don't add them. It's not 30. Multiply. Shh. Now, what do I do with the 200? Factor tree. There's definitely a bunch of factors of 200. I'm going to start with 2 and 100. And then 10 and 10. And there we go. Now, that's not typically the way I see students do it. It does work that way. Normally, I would see... Oops, hold on. I'm going to lose it.
Wait,
there it goes. Hold on. Normally, I would see people do 5 and 2, 5 and 2. But the 5s and the 2s both come out to make a what? 10. So if you see 10 and 10 and you want to stop there, you can. If you want to keep going, usually everyone just keeps going until it's all primed. That's kind of how I do it. But this is pre-programmed, and sorry to burst your bubble. I did not write this PowerPoint. So there you go. 10 square root of 2 is what I'm after. Any questions? All right. Example 2. Fractions indeed. When I multiply fractions, what do I do?
You get the tops together.
You multiply the numerators, you multiply the denominators. Okay? So I'm going to get square root 125 over square root 36.
Doesn't that simplify down to 6?
So yes, square root 36, that one you can do like rapid fire, right? That's just a 6. Up top, that's going to be a little more challenging. We'll do a tree off to the side. We get 525. 5, 5. Who's coming out? The 5s. Who's stuck inside? Another 5. So 5 square root 5. That's my numerator. And then the 6 is my denominator.
Wait, how did you take the
Oh, so if you find the square root of it, then it changes to 6. Yeah.
Yes, and we're going to talk about that from your quiz. A lot of you, after you took a perfect square, were still putting it in a square root. We're going to look at one from the quiz specifically. But yes, once you find the square root of 36 is 6, no more radical.
Wow.
Just the 6.
Somebody just got here.
Okay, so I have parentheses, right? Something being multiplied by a set of parentheses with a plus sign. Distribute is the magic word. Yes. So I'm going to multiply 2 by the square root of 3 and the square root of 3 by the square root of 3. Now, up front, these two are not able to actually make a 6 because the 2's on the outside, the 3's on the inside, so you just write it like this. However, 3 and 3 are both inside, so you can keep them in a radical and actually multiply it out. Now, 3 times 3 is 9, and the square root of 9 is 3. Now, here is where I see some problems, and it has to do with like radicals versus unlike radicals. This one doesn't have a radical. This one does. So you can't actually go and add these. This is the answer.
Well, can you put 3 plus?
You could put the 3 in the front if you wanted.
Because it looks like you would put the radical extended.
Oh no, so that 3 is just stalking it from outside its window?
Yes. But it's not. So this guy's playing outside, this guy's stuck inside, and this guy's just watching it all.
He's like that creepy guy who walks his dog.
Yes, exactly. Exactly what I was thinking. Okay, there's one other thing I want to point out to you, because this is going to come into play a little later. When I did square root of 3 times square root of 3, what was the end result? 3. That is not a coincidence. If you do square root 5 times square root 5, you will end up with a regular old 5. If you do square root 7 times square root 7, you'll end up with a regular old 7. Because you're making a perfect square. And then you're taking the square root. Do you see what I'm saying?
So it's just like the other thing.
Yes. So yes, once you get good at this, you could just make it a 3 right away. All right. Example 3, part A.
Whoa.
Less of all that. Okay, step number 1. They're both in radicals. The numerator is in a radical. The denominator is in a radical. And you can see that one is divisible by the other. So I'm going to make it one big radical, and then I'm going to simplify the fraction. So I made it square root 56 divided by 2, and then I did 56 divided by 2. And I got 28.
This is way harder
Now I can do a tree for 28. And who's coming outside? The 2. Square root 7. What are your questions? Next. Oh man, this is where it's gonna get good.
Square root 5, 6.
Good. Does it have to get good? Can we just leave it at home?
All right, if you've started to drift off, drift back in. It's getting good here. It's getting good. Okay. So this one's kind of the opposite approach. I had one fraction. It doesn't simplify. There's nothing to do with 5 over 6. You can't do anything. It's as simple as it's going to get. So now I'm going to focus on taking the square root of the numerator over the square root of the denominator. There is a problem here. We do not... Everybody put your pencils down. Put them down. I'm going to go back. Here is a giant rule. Are you ready?
No.
You do not leave radicals in your denominator. Ever. Ever. Never.
Ever?
Ever. Ask me about it. Never. But maybe, no, never. Okay, so we're going to use that magical trick that I was just talking about. If I want to get rid of a square root 6, the trick is to multiply it by a square root 6. Because that would give me square root 36, which is regular 6. Now, in a fraction, if you're multiplying the denominator by something, you best be multiplying the numerator by the same thing so that you're not changing the value of the fraction, because this is just 1. Okay? So, 5 times 6, both in radicals, gives me square root 30. Square root 6 times square root 6 gives me square root 36, which ultimately gives me a regular 6. That's the trick. You could do a factor tree for 30. Let's just talk it out, though. 5 and 6. 2 and 3. Are there any repeaters? No. So you could do a tree, but nothing's going to happen. It is a useless tree. What are your questions?
Hold on. If the alphabet is in math.
Hold on. Well, pause. Is this a question about radicals? Is it a question about the process of rationalizing the denominator? That's what we just did, P.S.
Right, I'm kind of confused.
What?
I just don't understand how to do it. I was paying attention for the most part. I just don't understand.
Okay, so shh. That's fine. What's the thing I can never have? A radical in the bottom. The trick to getting rid of a radical is to multiply it by itself, because then you make a perfect square, and then you take the square root of that, and the square root's gone. So square root 6 times square root 6 is square root 36, which is regular 6. But you can't multiply the bottom by something and just forget about the top, because then you're changing the number. But you can multiply it over itself, and that's just multiplying by 1. So we multiply top and bottom by square root 6. We end up with the radicals gone, rationalizing the denominator, and then I end up with square root 30 in the top. If you don't believe me, type this in the calculator, then type this in the calculator, you get the same thing. Yes?
Wouldn't we just, take the square root of 30?
You can't take the square root of 30. If you do a tree, let me show you the tree for 30. The tree for 30 is 2 and 15. 3 and 5. Does anyone go outside? No, that's why we didn't worry about the 30. There are no repeating factors of 30. Okay, so what's the problem? You can't have a what in the what? You can't have a radical in the denominator. The trick to getting rid of a square root 3 is to multiply it by square root 3. The same thing. If you do it to the bottom, you got to do it to the top. Up top, the 5's playing outside, the 3's in the house. They're not going together. In the denominator, square root 3 times square root 3 is square root 9, and the square root of 9 is 3. Now, check this out. We have a square root 3 over a regular 3. Do you think that simplifies to 1?
No.
It does not. Same idea as multiplying. You can't divide from inside and outside. If they're both inside, go for it. If they're both outside, go for it. These two are not playing together, even though they're the same number. Questions? All right. Yes, sir.
Can you simplify?
Yes, we can simplify this first. What is 5 over 30? 30. Oh my gosh. I don't know why I always do that.
5 over 35.
It's 1 over 7. Now, people always forget this. What is the square root of 1? It's 1. Yes.
But 1 times 1 is there.
Because 1 times 1 is 1.
But
So
does that
1
make-
squared is
Does
1.
that make 0? Two, 'cause you're-
Yeah.
Oh no.
Okay.
Use my brain.
Is this my answer?
No. There's
No.
radical in the denominator.
You can't have a radical in the denominator.
They multiply the
Are you answering the question or are you going to ask some obscure math question?
Yes.
Put your hand down. How do I do this?
top and bottom by the radical.
Top and bottom by square root 7.
I do have a serious question though.
What's 9 plus 10?
Yes.
Like what if we have like say how we had the square root with the squared symbol on the outside? What if we have the square root symbol in parentheses and the 0 for the
Anything to the 0 power is 1.
I
So
know,
the whole
like-
thing would just be 1.
Okay. So what is like change anything or just make it 1?
Just a 1. Okay. What is 1 times square root 7?
Square root 7.
What is square root 7 times square root 7?
49.
Square root 49, which is 7. And then this becomes a 1.
7. I mean square root 7.
Does it become anything else?
No.
That's it. The 7's in the radical, the other 7's not.
He's just creeping up to the
Yeah, it's like by 7. Okay?
he's creeping up to the
By Felicia without the Felicia.
I feel like we might be getting a little too deep into the house analogy.
That's really good.
You guys are getting a little wound up. I think the weather's getting to you.
It is.
Or the Pi Day excitement is just in the air.
It's the weather. It's my
Oh, for me it's the Pi Day excitement. I can't handle it. Okay. What do you think we're going to do?
You got this.
Well, they're not going to
Take the square root of 81 and 8.
Yes. We are going to break up the radical. Square root of 8 on top. Square root of 81 on the bottom. Which one are you the most excited about?
81.
I'm excited about the square root of 81 because the square root of 81 is 9. And 9 over 9 equals 1.
Yeah.
So now I just have square root 8.
Whoa.
Yes.
Yeah.
This 9 out front is a whole number. So if you want, you could think of it as 9 over 1. So then the 9 has to go up top. Now, you might feel like you're done. But,
Simplify.
surprise, we can do a factor tree.
Simplify. Simplify.
2 goes out, 2 stays in.
I got teacher.
That is the answer. Any questions?
No, man.
Which 9? What is 9 over 9, Carmen? 1. So I just divided it out. There's technically a 1 here, but you just can't see it.
Still got like
Can this be the last one? Isaiah, you were thinking of way too much.
All right, I'm going to do a tree for the 24. That is not the only approach. You might do square root of 24 times square root of 24, top and bottom. I wouldn't do that yet. Try to simplify it first. So here's what my tree looks like. I think you guys are pretty good with the trees by now. So the 2 is going to come out. And then I'm left with a 6 on the inside.
We gotta multiply it by 6.
I will multiply the numerator and the denominator by square root 6. But first, I'm going to simplify the 4 and the 2. It's like 2 over 1. Now I'm going to worry about the square root 6. So I am going to end up with 2 square root what on top?
6.
2 square 30.
Square root
Over 6.
30, yeah. Over regular old 6 because I would end up with square root 36, which is 6. Am I done now? No. You can simplify even further because now the 2 and the 6 are both playing outside, so you can simplify them. What is 2 over 6? 1 over 3. So my answer is square root 30 over 3. I will say this many, many times as we do this. There are a lot of ways to arrive at that answer. Okay? Like I said, some people will automatically start multiplying by square root 24. As long as you're doing the math correctly, you could do it a completely different way and still end up right here. So if you're comparing notes with someone, there is not just one way to do this. There's a lot of different ways to arrive at the same answer when you're doing radicals. Any questions on this way? All right. Now, here's the next one. Remember, numerators multiply numerators, denominators multiply denominators. Outside the house stays outside the house, inside the house stays inside the house.
That's a lot.
So, I am going to multiply the outside numerators, 2 and 1. The outside denominators, 3 and 2. The inside numerators, 4 and 15. The inside denominators, 5 and 8. Now, along the way, some things happened that you can't see. Like, these were simplified. That's where the 1/3 came from. These 2 were simplified. These 2 were simplified. Okay? So once you have, fractions together inside or outside the house, you can still do your old fraction tricks. The cross canceling. Okay? So that's how that multiplication was done so quickly. So outside the radical right now, I have 1/3. Inside the radical, I have square root 3/2. Can I cancel these 3's? No. This one's inside. This one's outside. It is tempting. Don't do it. Any questions on how we got to this point? Because the next step will erase my work. All right, so now I'm going to take square root of the top, square root of the bottom. I've got one small issue, and that is the square root 2 in the denominator. How am I going to get rid of square root 2? Multiply top and bottom by square root 2. Up top, I get square root 6. On the bottom, what is the square root of 2 times the square root of 2? It's the square root of 4, which is the number 2. What is 3 times 2? 6.
Can that be the last one?
No.
Can't do that. Are we gonna have homework tomorrow?
Whoa. Don't start. You're just going to slow us down. Okay. We will call this the last example of the day. Square root of 2 over 2. How'd you do that so quickly?
I just took the square root of 4.
Yes. 4 is a perfect square. Don't overlook the obvious. Sometimes students make this a lot harder than it is. Don't start multiplying by square root 4 over square root 4. You've already got a perfect square. You don't need to make one. You got one. So don't make these harder than they need to be. What are your questions on multiplying and dividing radicals?